Welcome to Scaling Advanced Analytics. It will provide you with an in-depth advanced analytics training using SAS language. I'm your instructor for this course, Sofiane Misbah. Here's a short demo about myself. I've been really interested about this topic since 2001. I obtained my master's degree in 2006. I have consolidated my modeling skills while working across major companies like Ernst & Young, Axiom, HSBC, Lloyd's TSB. I currently work as a data scientist for a media company. Let's see an overview of the whole course. This course is aimed at data science, and specifically advanced analytics professionals. I will be using SAS programming language and statistical methods. Let's consider a giant file where each line is an individual and each column characteristics. Big data enables scaling computing power to deal with files that have too many rows. Big analytics enable us to scale analytical methods so we can deal with files that have many factors. Big data remains simple because it scales the processing power across several computers. Big analytics will be more challenging because we analyze each dimension differently. We will learn a framework to generate algorithms more easily. This will enable us to scale advanced analytics work from high-dimension datasets. High-dimension datasets are datasets with a large volume of factors. The SAS software is required. Note that if a commercial edition is not available, SAS University Edition can be used instead as a learning tool. Basic and intermediate SAS programming is required. Understanding statistical inference and principles of linear and logistic regression would be beneficial. Statistical modeling will be used to illustrate the scaling tools. We will go through the key concepts first. I will explain data-driven programming, data preparation algorithms, dimension reduction, and finally regression adjustment algorithms. This section will emphasize on the approach taken to teach our scaling tool. We will first explain the modeling framework chosen to illustrate scaling analytics. We will then explain why differentiating numerical and categorical variables is essential. We will not demonstrate our methodology using decision tree or neural network type of models. We will instead choose inferential statistics model framework. Statistical inference is an essential part of our scientific methodology. Inference-based models are very popular in business as well as science communities because they give a transparent view about each driver's weight. They provide a well and balanced model that is easy to implement. We will focus on multiple linear regression to estimate a continuous outcome and logistic regression to estimate categorical outcomes. These methods will provide accurate and stable estimates. The outcome of the model is simple to interpret and provide a transparent view about each driver's weight. They require, however, more data preparation in order to meet assumptions that will guarantee model stability and accuracy. We will distinguish two types of variables, numeric and categorical. Numerical variables represent a quantity, for example, age or weight. Categorical variables represent groups, for example, gender or eye colors. Information is represented, summarized, and interpreted in different ways for both types of variables. For example, age might be better summarized with means, while gender may be with percentage. Distinguishing continuous and categorical predictors is especially important with big data. For example, if we describe frequencies for numerical data, it will not make any sense and will overload the server. On the right side, we have an example. We can scroll down and see that each distinct value is in the frequency table.